Okay. Let's start. I'm not Stacy. So my name's Mark. I'm filling in for her today. She's on some official important business somewhere, but she still loves you. And she said you have a bio to turn in. That's right. And then Module 1, Section 4 homework. So that you have 2 stacks up there. That's due now, right? So here's your chance. Okay. So I think that's all we'll just get started. If you have laptop with graph and calculator, we're going to do a lot of that today. So you're starting to get your feet wet with graph and calculator, right? And so if you had questions on the homework, very possibly the things we do today might clear those up. If you still have questions after that, then you have your support system. You could catch me after class if it's a quick question, but you have your whole support system of Cerny, and just get your questions answered, okay? But we're going to start with this example. Let's see here. Back from module, you did module 1, section 3, right? But you've done section 3 previously. Is that correct? Do you remember this problem with the sunflower?
Yes.
All right, so we're going to talk about this sunflower problem and then expand on it. Okay, so we're going to all our conversation is going to be about this. We'll do a little bit from that homework, but mostly new stuff. Okay, or just kind of review. So let's see. That's okay. So let's just get warmed up here. So the function h of t is given here by this rule. So cubic polynomial. It gives the height of the sunflower in t days after the seed germinates. Okay? And the function is valid for the first 10 days, from 0 to 10 days. So just as a warm-up here, you can talk with the person next to you. What is this, when you read h parentheses 6.14, what are you looking at there? What does that mean? So this is going to be crucial in the whole course, that you have a firm and quick understanding of something, a notation like that. And then what would h of q equals 6.14 represent? So have a quick conversation with the person next to you. Talk about these meanings of these expressions. Go. Okay, so let's have a volunteer. So when you see that, and that's this first one, you would say h of 6.14. H of 6.14. What does that mean? You can give me a full, specific, detailed. Yes, sir?
It's the height of the sunflower after 6.14 days.
He said the height of the sunflower after 6.14 days. What do you think? Yeah, so this is function notation, and it means, when you see function notation, it means the output quantity. It means the output quantity, in this case height, okay, in centimeters, and then after 6.14 days, that at a particular input. So it's an output at a particular input, or the height in centimeters after 6.14 days. All right, what about somebody else? H of q equals 6.14. What are we representing there? What would that represent? Somebody new? Yes, sir?
At q days after the seed germinates, the function equals 6.14 centimeters.
Okay, and the function equals, so what is the 6.14?
So that's an output.
And what is that?
The height. Yeah, the height of
The height, etc. So after q days, the height is 6.14. So now our q is representing a number of days, the input, and the height and 6.14 is the height at q days. Okay, so now in homework B, it says, did you go over this in class, homework B, without using any graphs? Figure out when the sunflower, how long it takes to do 40 centimeters? I don't want to be redundant. Okay, cool, let's do that. This is a cool question here. So we don't want to algebraically solve for t, and we don't want to use the graph. So what could we do to figure out when it reaches 40 centimeters? What could we do to figure out when is this height going to reach 40 centimeters? Or in other words, what input will give us a height of 40 centimeters? Can't solve. What's that? Yeah.
X days into the function.
Okay, x days into the function, and then what do you want to do?
So you can just do it in function notation, so h of x equals 40 centimeters.
Okay, h of x equals 40. Now we want to find that value x. What can we do? Yeah, she's saying h of x equals 40. That's exactly right. How can we actually get this number? We want to know how many days to reach 40. What could we do? Yeah.
Can we set our equation equal to 40?
Yeah, but so that's off limits. That's what I'm saying. You can't do that. You can't solve for the input. But yes, that's one way to do it. So you're desperate. You have to get this number. What are you going to do? So anything's fair game except solving for the input and using a graph.
Guess and check.
Guess, right? Guess. So let's use graphing calculator to do that. Oh, come on. Already? Gee whiz. Okay, so what do you want to guess? And so here's the beauty of a graphing calculator. You can define the function, and then you can just use it, and it just cranks out values instantaneously. Okay? Remember when you define a function, I'm sure you've talked about this, you have to have control. When you do the parentheses, you have to do control 9, not shift 9. Shift 9 parentheses are like what you do for multiplication or grouping. But if you want to use function notation, define a function or use it, you have to do control 9. Okay? So if I do control 9, so 5 days. Just throw 5 days in there. What do we got? 27. So in this first line, it's defining the function. But in the next line, we put that notation in, and like you said, h of 6.14 represents the height at 6.14 days. Graphing calculator works the exact same way. You put in h of 5, and it's saying, oh, you want to know the height at 5 days. And it tells you, 27. So now we want to get the height. When does it reach 40? How am I going to change my guess? Bigger or smaller?
6.45. 6.45.
Is there... Was it? So 36? Bigger or smaller?
Bigger. Longer. More time.
Okay, thanks.
6.5.
Okay, so we're getting closer. That's too big. And so this is the beauty for graphing calculator. I can just keep changing that input, and it just will give me the corresponding output just like that. And I can just revise this. So if I try 4 or 5, I'm getting still a little too big, still a little too small.
767. 4476.
448.
Yeah, 1448.
Let's do 3 decimal places, 448. Okay? All right. Okay, so let's talk about the next question in part C. It says, represent the change in the sunflower's height between 7 and 9 days after germination. Okay, before we do that, let's just talk about changes, notation, what we mean when we mean a change. So let's just talk only about, here's this axis here for number of days. Okay, so suppose I'm starting at 7 days. Starting at 7 days, and we're ending at 9 days. Have you guys talked about how, so this is a change in the number of days from 7 to 9. Have you talked about how to represent that amount of change? Yeah?
Yes.
What is it?
H of 9 minus H of 7.
No, I'm just talking about days. I'm just talking about days, not height of the sunflower. So if you talked about how to represent a change in any quantity symbolically using a symbol. Okay, so if whether you have it or you haven't, it's delta. Okay, so delta. Okay. So delta. So I'm using d as my input variable. So it's also delta d for days. Okay, so delta d means the change in the number of days. And what is it for this going from 7 to 9? That amount of change is 2. Okay, the attitude's a little distracting.
I'm sorry.
Yeah. Okay, so what about if I started at 1 day and went to 3 days? Okay, so is this a different change in days or the same change in days? Is this different or the same? People are saying the same. What is the same? There is something that's the same. What's the same? The amount of change. But is it the same change in days? No. So this, when we do the change in a quantity, it's like a new quantity, but it's kind of a different animal than the original quantity itself, because I can have a change of 2 in many different places, starting at different times, and I can still have a change of 2. D equals 2 means one thing. It always means the same thing. It means 2 days since germination. But delta D equals 2 is kind of different because it's an amount of change of 2, but it's kind of it's mobile, right? It could start at 8 days. It could start at 12 days after germination. So it's a little bit different. Change in days of 2. Okay. So now we've got a delta D of 2 from 7 to 9, and we want to know how much did the height change when the days changed from 7 to 9. So how am I going to calculate how much the height changed when the number of days changed from 7 to 9? What about if I take delta D2 and I put it into so I got the change, I take the change, put it into our height function to get the corresponding change in height. Does it work? I'm going to take this 2, since that's the change in days, put it into this. It's going to give me that change in height that I need. A few people are shaking your head. That should feel uncomfortable. That's not right, because if I put 2 in that function, what does it mean? Yes. So if I do h of 2, what does that 4.8 mean?
The height it was at day 2.
Height it was at day 2. Okay. It's not the corresponding change in height that you get when 2 days go by. All right? But calculus students throughout the ages have tried to do this. So don't do this, okay? Because 2, the input into the h function is a number of days since germination. It's not a change in the number of days. So you can't do that. So instead, how are we going to get the change in height? Yes, we would need the final value of height, just like you would do 9 minus 7 to get the change in days. You need the final value of the height minus the initial value of height. So it would be h of 9 minus h of 7. Notice, a whole lot different than h of 2. H of 2 is our height at 2 days. The change in height from day 7 to day 9 would be the final height minus the initial height, 14.6. Will that be the same change as from day 1 to day 3?
No.
Not necessarily, and probably not, right? So h, so we do it again, h of 3 minus h of, h of 1. Come on. Gotta start over. Something. Oh, I got that on. Okay, so notice 3 different results. H of 2, H of 9 minus H of 7, and H of 3 minus H of 1. All have different meanings and therefore different values. Okay? So H of 2, what's that? The height at 2 days after germination. H of 9 minus H of 7, a change in the height if days change from 7 to 9, and H of 3 minus H of 1, a change in height if days change from H of 1 or from 1 to 3 days. And so you get a different different number of centimeters in each case, because all different meanings. All right, questions so far before we get to graphing? So this is looking at function notation, some different things. Okay, so now we want to graph this thing. Going back up to our original h of d equals this, and I want to propose that we do, to graph it, so bringing y into the mix, then it's talking about the y-axis. So what about y equals h of d? Okay, so my function, I defined it as h of d, and so I'm going to graph now y equals h of d. So I want you to talk to the person next to you. What are we going to see? First of all, is it going to graph anything? Am I truly telling graphing calculator to graph something? And if so, what? Okay, talk to the person next to you. Go. Okay, will it graph something? Yes. Will it graph this function of height and days? Yes or no? Oh, I should have told you not to try it. If you have graphing calculator open. Does it do that? Answer is? Well, yes, it graphs something down here. But is this the height of the sunflower as time goes by? No, this looks like a constant function, right? It looks like a horizontal line, a constant function, meaning that it's not growing. We know that's not true. We know this sunflower is growing rapidly. Okay, so really, and what this turns out to be is the horizontal line at y equals 1. Y equals 1. So is graphing calculator messed up, or what's happening here? Yes, sir?
You have to define what h of d is. Like, so it puts into the something.
We defined the h function, h of d. So why doesn't y equals h of d work to get us the graph?
I think we need to give it an X.
Okay. So we need to give it an x. But what happened here? So why didn't this work? So x is the way that we'll get it to work. Yes, sir?
It's assuming that d is 1.
Okay. Right, if you look over here, d has two very different meanings in this line and in this line. In this line, it's the placeholder for the input, because we're defining a function. We could have used any letter we wanted to be in the parentheses there for the function notation, and then be our input variable in the rule. And it's just a placeholder. It's just the input of the function. But now, in this line, d is actually like a parameter, like you've been defining parameters in GC, like a variable. And if you haven't said what it is, then by default, right here, if you see right here, d is 1. So because d is 1, that's why it's graphing it as y equals 1. This line is y equals 1. Is that right? Is that why it's graphing it as y equals 1? Nope. We're not graphing y equals d. What are we graphing?
Input x. So the height at d, which would be 1. So it just graphed the height at 1.
The height at 1. It's graphing the height at 1 day. It's taking the 1 by default and giving you the height, which coincidentally is 1 centimeter. Coincidentally, you plug 1 in this function, you also get 1. That's why it's graphing y equals 1. Not because it's graphing d equals 1, but the height at 1 day, which just happens to also be the numerical value 1. This is 1 centimeter. Okay? So he touched on how are we going to actually get the graph here. We want all inputs and all corresponding outputs. So graphing calculator for all inputs is x, okay? And then corresponding outputs are y. So h of x gives us this curve, but we have a restriction, right? You guys have seen this. We only want it from 0 to 10. Question?
Yeah, I had trouble with this when doing it. How do you get less than or equal to? I could only get less than.
Okay, so for a Macintosh, it's option less than and option greater than, and then for PC, control shift less than, control shift greater than. So yeah, so you need control for PC and option, use just option for Mac. Okay, so here it is. So if you haven't yet, so get your axis scale to look just like this. So we're going to graph it. Everyone's got GC open. Get it to look the same rendering of the graph in terms of your axis scales. You should be able to do that. Anyone? And hopefully, if you don't have it, if you do have it, and you let someone next to you look over your shoulder, and if you don't have it, look over somebody's shoulder. So everyone's can look at a screen. We want to get it to look like this.
Option. Oh, for Windows?
Because after,
Anybody have a question? We good? Okay, so let's go back to this number C and let's look at a representing this situation in C graphically. So we're going to represent that graphically. So we said our change in days is from 7 to 9. So there's our 7 and to 9. No, before I do that, I want to talk about when you see a graph like this. So we'll get to that in a second. When you see a graph like this, what is your image of what you're looking at? What is your image of what you're looking at? You've seen graphs like this your whole math career. A curve or a line plotted on two-dimensional axes, right? What is your image of what that is showing? Yeah.
the height of the sunflower in centimeters of further amount of days elapsed.
Okay, so it's a representation of height of the sunflower versus days elapsed. So, but my question is more about this curve. If it's any curve or any line, what is it that you're looking at? Someone new?
It's constantly changing.
Constantly changing. Okay, but I'm talking about any graph. It could be a horizontal line. It could be a slanted line. It could be a curve. I'm not talking about this particular one. But what is your image when you see any graph? Yeah.
It's moving. It's going up.
It's moving.
Yeah.
What's moving?
Just the relationship.
The relationship between two quantities. Okay, so moving. So it's dynamic. Something's dynamic.
That's what I'm trying to say.
How something changes according to how something else changes.
Okay, how one quantity is changing related to how the other is changing. What does that curve consist of?
Points.
Okay, so points. This is crucial. So if we put all what you said together, you guys all had a bunch of good comments. If you put all those things together, this is what you should imagine when you see a graph like that. Okay, so you imagine point by point, this graph emerges as the days increase. And each point represents what? So if we pause it here and look at a particular point, we're getting lots and lots of points. If we come here and we look at a particular point, what does it mean?
The height at that specific time.
Yep, it's two values taken together. a time in days and the corresponding height. So as the days increase, these points emerge, each point giving you the number of days and the corresponding height of the sunflower. So when you see just a curve or a line, your image should be this. No, not that. This. That as your input quantity increases, you're going to have for each value of that input quantity, you're going to have a corresponding value of the output quantity, and then that creates a locus of points that emerge as that input quantity increases. So whenever you see something like this, you think this. Okay, so now back to our part C. And we're looking at the change in height from when the days change from 7 to 9 days. Okay, so how is the height at 7 days represented by this graph? How is the height at 7 days represented by this graph? Somebody new. Tell me. So this graph tells us something about what's happening at 7 days. How does it do that?
Represents an input and an output at a specific point on the graph.
Okay, a point, right? Yeah. So at 7 days, there is a particular point that's part of forming that graph. And where does the graph show the value of the height? Where does the graph show the value of the height at 7 days? Does it show it at the point? No. Okay. Yeah. So the y-axis, or it's like a vertical length, right? So to see actually what that value is, it's that number on the y-axis, which represents a vertical length from the x-axis. So from here to here, what that length is, and how do we represent it symbolically? H of 7. You should all be thinking that, even though you weren't saying anything. H of 7 is the height of the sunflower after 7 days. We see that value on the axis here, and it's this length right there from the x-axis up to that point. You could think of a segment like that, and that's H of 7. Okay, and so then this point represents 7 days and also the height at 7 days taken together. Similarly, 9 days has a point somewhere up here. The coordinates of that point are 9, H of 9. So now how can I visually here represent that change in days from 7 to 9? I can start at this point and go up, down, left, or right. I want to represent the change in days starting at 7. From here, go up, down, left, or right. The change in days. Right. Not right and up. The change in days. The change in days. That's the x quantity. So we're only going left and right if we're talking about the change in days. So this bar right there represents that delta D of 2. And then from here but you're right, when 2 days went by, the height increased. How can we show that amount of increase? From there we can go up. Okay, so this right here is 2. And what's the amount of increase? We did it before, but now it's visually shown. So the length of this bar right here, how can we show it symbolically? Yes, ma'am.
H of 9 minus H of 7.
H of 9 minus H of 7, the change in height. Any questions on that? We could also just shift that over here, and I could show that change as, say, a highlighted bar over here, where the top of it here is H of 9, and that's H of 7. That would also be the H of 9 minus H of 7, the change in height as the sunflower grew from 7 to 9. That grew over day 7 to day 9. Okay, so, and we saw we can get these values exactly in Graphing Calculator up in the command lines by using function notation. You can just plug in h of 9, it tells you what it is. Plug in h of 7, it tells you what it is. Another way to get function values once you have the graph is if you click on the graph, crosshairs come up. Okay? So and then if you move the crosshairs, if you see up here in the corner of the graph, it gives you it gives you approximations for the current values of x and y, ordered pair. So right now, I'm showing 5.475 for x and 30.9257 for y. Or something like that. 5.4375 and 30.9237 as a ordered pair for where the crosshairs are. I can drag it. And so I'm going to put it right on 7. Just put the cursor right on the graph and click, and then the crosshairs come up, and then you can drag the crosshairs, and it gives you gives you the current ordered pair depending on where the crosshairs are. Okay, so I want to talk about actually plotting points with Graphing Calculator. So if you start a new command line, if you want to plot a point, you use Control 2, and this is what comes up. It's like a vertical vector when you do Control 2. Everyone do that, Control 2. And so I can come here and I can say graph and then put in 8 for x and 10 for y. So now I've got the graph still graphed here, and then I have this new point 8, 10. Okay, so where did I have the crosshairs before? At 7? So I'm going to come up here, and now I want to plot that point on the graph. So I'm going to do the same thing instead of 8, 10, or I can just leave the 8, 10. That's fine. New point. I'm going to do Control 2, and it was 7 and 44.8. And graph it in red. And that's a point on our graph. Right? It's a point on the graph. Is that right?
Yep.
Oh, it's not. Why not? What happened? Sure looks like it. I put in the numbers according to what the crosshairs told me. What's going on here? Why? Yeah.
Well, it's more than just a point on the graph. It's the height of the sunflower at 7 days.
Okay, so 44.8 is the representation is days and height of the sunflower. But is that red point, is it a point on the graph or not? Well, I already told you it's not. Majority doesn't rule in this class, okay? You all thought it did. It doesn't. Why not? How about one of you guys in the back? 7, 44.8. Is that a point on the graph? Yes, sir.
Is it because 44.8 isn't a point, it's a line?
No, not quite.
It's because you're not talking about the relationship, you're just giving like two like numbers, like you're not saying that the height is related to days in any way, like you're just saying 7 and 44.8.
No. Yes, sir.
Is it because it's artificial? Like we just put it there, it's not actually part of our function?
What does the graph consist of? Points. I just plotted a point. Is it one of the points on this graph? No. Why not? Let's do something here. H of 7. Oh, wait a sec. Maybe I picked a bad example. Let me do what? 7.5. Okay, so I maybe picked a bad example. So how about let's do 7.5 instead. Can I get exactly 7.5? There we go. All right, so I'm going to do 7.5. I really do know what I'm talking about. Just picked a bad example. 7.5 and what? I got to. What comes up here? $48.9375. How about that? So now I pulled off those numbers, 7.5, 48.9375, and I plotted it. Is it a point on the graph? What am I getting at here?
It's infinite,
What's infinite?
the number of points on the graph.
Okay, that's
Another
true.
one.
It's not an exact number.
Right. This is as far as we know, this is a decimal approximation. It's a decimal approximation. So it's really close to a point on the graph, but it's not necessarily actually a point on the graph. So here's your first task. I want to truly graph the point on the graph at 7.5. It exists, and I want to graph that point. I don't want something really, really close. Okay? This is just an approximation. The decimals could keep going on. So I want to truly graph that point on the graph. How am I going to do it? So that's your first task. So you figure that out with your partner. And then I have a series of other tasks for you as well. So I had it. I had a 4.25 is what I had. $20.4797. Here's another example. There's the example in this 4.25, and when I use the crosshairs, I get 20.4797. Okay. When I use the crosshairs, I get 20.4797. If I just plot those as those numbers that the crosshairs gave me, I get a point. It's close, but it's not truly a point of the graph. So how would I change this to truly make it the point on the graph that represents the days and height at 4.25? So everyone work on it. We'll walk around and help you if you need, and then work on these. Okay? Then work on these.
So I'm saying like instead of choosing like about.
But once you get, once that brings the actual, I mean, I don't know if we'll be able to tell, but that's the actual point. I don't know how you find it. I bet you I have no idea how to take that's I never figured out lesson. I was like, lesson.
It's an irrational number. You're just, as long as you do a decimal, you're cutting off it somewhere, and that's an exact. For practical purposes, if you're measuring the sunflower, that's a different issue, right?
But like in mathematics, you can't ever.
Irrational numbers, infinite non-repeating decimals, right? So to represent exactly, you need that. Okay, for time's sake, I want to. So some people figured it out. What can I do instead? How can I get this to be the exact y value that I need?
No, put in h of 2 or 4.25.
Here, so this is, we're trying to emphasize function notation. H of 4.25 is exact. Okay, so that, yes, the point ends up in the exact same place, but there's a difference between putting a really close decimal approximation there, which truly is not a point on the graph, and then using h of 4.25, which then represents the true, according to the function, the true height of 4.25, and that's truly a point on the graph.
Is that kind of related to your d equals something and change it to equals something?
What's that?
So you started out the class with d equals 2 is different than delta t, or d equals
Uh-huh.
2. So are those two kind of related?
Not really. Not really. That's no. That's kind of a different topic. Yeah. Question.
This might sound stupid, but how you were talking about like how whenever I know the rational, how do you know that like would be a function? I guess like do we just assume that for any function that it's
It's not
going to
repeated.
be an irrational like answer?
Well, for very easy, simple functions, you can see, right? But the point is that this is always the true value of the output,
Regardless if it's irrational.
regardless if it's rational or irrational. You can always represent the true value of the output with the function notation. Other questions?
Is that like the exact, or is it rounding off at the 4 decimal places?
Graphing calculator is rounding that, okay? But the representation is of the exact value. That means the exact value.
Yeah,
Yes,
you
sir.
can even see it if you go into like edit
Uh-huh.
and set the decimal places that it'll round off. I think it's like 8 digits or
I
something.
don't know.
Oh, so there's more digits.
It's like 8 digits that it rounds
Okay.
How'd you do that?
out. It's in edit.
All right, any other questions? So I want to now change our focus here to D through E. We want to another plant, say it maintained this height, okay, h of 4.25 at all times. It does not grow or shrink, the 20.4797. I want to define a function k for the height of this plant as a function of t, the number of days, the same number of days. So we have the same input quantity, and now we want a function k that gives us the height of this new plant that maintains this height for at all times. At all times. Can you define that function? Can you define that function? Come up here. So we want a new function called k. All right, and we can also have it be. So watch what happens if I don't use control. If I do shift, it's immediately thinking multiplication. Okay, and you can see that the parentheses are not quite hugging as close to the k as they are to the h. That's kind of one little thing. If you use the parentheses, they'll be offset to the right a little bit. So I need control. So right now this isn't thinking function, it's thinking multiplication. So I need shift control 9. Okay, and so now if I do D equals, how am I going to define this function to be the way I've described it? Another plant maintains this height at all times. Define the function k for the height of this plant as a function of t, the number of days, and then graph the function, but only graph it starting from the y-axis and ending at point P, which is our 4.25 point. And then graph a vertical line segment from the x-axis to the point P. So this is your task here, and hoping for one more task after this. So can you move quick? So can you define that function k of d and graph it from the y-axis to the point P, and then a vertical segment from the x-axis to the point P. Go! This is the point P right here. That we've graphed as 4.25 and h of 4.25. So now we have a second plant according to function k, and I want to graph its height, which maintains the height at all times. Maintains the same height as the sunflower at 4.225 days, but at all times. And I'm going to graph that from the x-axis to point P.
I know what it should look like.
I think so.
How's that function going to be defined? K of D equals what? What will it be? Same as H of D? The same function?
Playing the same function.
Is it the same function? What is it maintains the same height at all times. It maintains the same height as the sunflower at 4.25 days, but for all times.
Oh, for all time. Oh, no.
Find the function K of D. And then you're going to graph it.
I don't know why it's not working.
Yep. What's not working? That doesn't graph it. That just defines it. Wait, to define a function, and then in a different line we have to graph it. Remember, this didn't graph it. This didn't graph it.
That's why.
This graphs it, right?
Yes, it just clicked. Yes.
You have to define a function. That doesn't graph it. That just defines it, just like we did here. This defines H. This graphs it.
Or you could also do Y.
So we want it to be the constant height of the sunflower of the sunflower's height at 4.25 days. How do we show that? Or how do we define that? H of? No, not H of D. If you do H of D, it has the same height profile as the sunflower. It always has to have this height. So we define K of D as H of 4.25. And now we graph it. Y equals K of D, right? K of X, not K of D. Then it'll plug 1 in, right? D is 1. If you do K of D, it'll plug 1 in. We want to graph the function, okay? And then from where to where? 0 to X to 4.25. Let's do it in blue. So you have to define a function first in one line. You have to graph it in a different line by using y and x. But our function is defined as this constant height, the height of the sunflower at 4.25 days. Okay, and then we started it at the y-axis, and we ended at the point P, which is x equals 4.25. Okay, one last thing. Sliders. There's a built-in slider in, this is for your homework for next time. You're doing section mod 1, section 5. So I want to talk about sliders. I've got a slider down here. Anytime you hit N, the slider appears. So if you just start a new line and hit N, the slider will appear down here. And what that is N is a variable or a constant that can be manually changed, or you can hit the play button and it just changes automatically, like it's playing something. Okay, so you can come down here with a button and grab it, and notice as I change N, maybe. Okay, it'll change the value of the current value of N. Then any line that has an N in it, it will use that current value of N wherever there's an N in any line in the graph, in the program. Okay? So if I were to come up here and do, say, 8 or n comma 8, then what will happen? The x-coordinate will change according to what n is. The y-coordinate's fixed at 10. But the x-coordinate will change according to whatever n is, because I'm finding the point n10, and n I'm changing down here. Okay, so if you want some warm-up for your homework, you have time to stick around. My next task for you was to try to create this. So if you want to take a few minutes and see if you can work on that, it'd be really helpful for getting ready for your homework. If you have to go, you have to go. But I'll stick around. Those who want to give this a shot, you got the point, and then you've got this line that we graphed before, but now it's changing according to n.